The Ober stood motionless in the courtyard of the Heereswaffenamt testing facility at Kummersdorf, 25 miles south of Berlin, staring at what his subordinates had just unloaded from a captured American supply truck. It was December 1942, and scattered around him on the concrete pad were 7 vehicles that would fundamentally challenge everything German military engineers thought they understood about automotive design, manufacturing, and the very philosophy of mechanized warfare. They were Willys MB Jeeps captured during the Operation Torch landings in North Africa, and they were about to humiliate some of the finest automotive engineers in the world. Major Hans Kniepkamp, Germany's chief designer of military vehicles and architect of the Wehrmacht's half-track fleet, circled the nearest jeep slowly, notebook in hand, his expression shifting from professional curiosity to visible confusion. He had spent 20 years designing military vehicles, had created the Steckhurst family of half-tracks that were engineering marvels of complexity and precision. What sat before him now violated every principle he had built his career upon. It was too simple, impossibly simple, suspiciously simple. The examination began with standard protocol: weights, measurements, component identification. The Jeep weighed 2,153 pounds empty. German engineers checked their scales twice, certain there was an error. Their lightest military vehicle, the Kübelwagen, weighed 1,143 pounds, and it was essentially a militarized civilian car. This American machine, with full 4-wheel drive, a proper frame and battlefield capability, somehow weighed only 9–10 pounds more while offering capabilities the Kübelwagen couldn't approach. Dr. Friedrich Porsche, invited to observe as a consultant, ran his hand along the frame rails. They were simple U-channel steel, stamped and welded, nothing more. No complex forgings, no intricate castings, no carefully machined joints. Just bent steel joined together like a child's construction toy. Yet when technicians applied hydraulic pressure to test structural strength, the frame withstood loads that would have crushed vehicles twice its weight. Porsche said nothing, but his frown deepened with each test. The engine made everyone deeply uncomfortable. It was a Willys Go Devil, a 134 cubic inch 4-cylinder producing 60 horsepower at 4,000 RPM. On paper, it was pathetic. Germany's military vehicles used engines designed to specific military requirements, high-grade materials, precision manufacturing, careful tolerances. This American engine looked like it had been designed by someone who had never heard of military specifications. The valve train was side valve, an archaic design that German engineers had abandoned years ago as inefficient. The carburetor was a simple single-barrel unit that German automotive students would have been embarrassed to submit as a class project. The electrical system ran on 6 volts, when everyone knew 12 was the modern standard. The oil filter was laughably small. The fuel pump was mechanical, driven off the camshaft like something from the previous war. When they disassembled the engine, expecting to find the secret of American engineering, they found something that made several engineers actually laugh. The internal components were crude. The machining tolerances were loose by German standards, so loose that they assumed the engine had significant wear from hard use. When they measured a second engine from an undriven vehicle, they discovered the tolerances were identical. The Americans had built them that way intentionally. The crankshaft, the heart of any engine, was particularly offensive to German sensibilities. It was a simple casting, roughly machined, balanced adequately but not precisely. German military engine crankshafts were forged from special steel alloys, machined to tolerances measured in 10,000ths of an inch, individually balanced on precision equipment. This American crankshaft looked like it had been made in a farm workshop. Hans Niebel, chief engineer at Daimler-Benz, picked up a connecting rod and hefted it thoughtfully. It was cast iron, not forged steel. Cast iron, the material used in engine blocks, not in high-stress rotating components. He handed it to his assistant without comment, but his expression said everything. These Americans were barbarians who didn't understand fundamental engineering principles. Then they started the engine. It ran perfectly. Smooth, quiet, responsive. They ran it for an hour at varying throttle positions, no problems. They ran it for 6 hours continuously at maximum RPM. It maintained oil pressure, operating temperature stayed constant, no unusual vibrations. They tore it down again expecting to find wear. The components looked unchanged. The loose tolerances that had seemed like ignorance were clearly intentional design choices. The sloppy clearances allowed dirt, dust and sand to pass through without binding. The simple side valve design meant fewer parts to break, easier maintenance, better reliability. The crude machining reduced manufacturing time and cost while maintaining functionality. The Americans hadn't built a bad engine. They had built an engine optimized for mass production and field reliability rather than performance specifications. It was a completely different design philosophy, and it was clearly working. The transmission brought new revelations: 3 forward gears and 1 reverse, synchronized on second and third, with a 2-speed transfer case providing high and low range for 4-wheel drive. German engineers studied the gear cuts under magnification, expecting precision German-style involute profiles. What they found were gear teeth cut quickly on high-speed machinery, finished adequately but not precisely, heat-treated in batches rather than individually. The synchronizers were simple brass cones, not the complex dog clutch arrangements German transmissions used. Everything was made to minimum acceptable standards, not maximum theoretical quality. When they tested the transmission on a dynamometer, applying the torture protocols used for German military vehicles, they expected rapid failure. The Jeep transmission absorbed punishment that destroyed prototype German gearboxes. The simple, crude components somehow proved more durable than their sophisticated German equivalents. An engineer named Wilhelm Haspel, who had designed transmissions for Opel before the war, spent 3 days studying the transfer case. It was a masterpiece of simplification, providing 2-speed reduction and front axle engagement with fewer parts than he would have thought possible. The entire unit could be disassembled with basic hand tools in under an hour. German transfer cases required specialized tools and factory-trained mechanics. But it was the examination of the vehicle's electrical system that began to reveal the true genius of American mass production philosophy. Every electrical connector was identical throughout the vehicle. Every wire was color-coded with a system so simple that even illiterate soldiers could follow it. Every component was mounted with standard hardware that could be replaced from common stock. The headlights were sealed beam units. The bulb and reflector formed as a single unit that could be replaced in seconds without aiming or adjustment. German headlights required careful installation, precise aiming, and adjustment by trained technicians. The Jeep's electrical system wasn't elegant, wasn't sophisticated, wasn't impressive to engineers, but it could be repaired by anyone with minimal training using parts that were completely interchangeable across thousands of vehicles. Dr. Porsche wrote in his notes, "The Americans have apparently confused standardization with engineering, yet one cannot argue with the results." The suspension system created fierce arguments among the examining engineers. It consisted of simple leaf springs, front and rear, directly attached to the axles. No independent suspension, no torsion bars, no sophisticated linkages. It was the same basic suspension design that had existed since the invention of the automobile. German military vehicles used complex suspension systems, carefully engineered for optimal wheel travel, minimum ground pressure, and superior ride quality. The Kübelwagen had sophisticated trailing arm suspension. Half-tracks used elaborate bogie systems with multiple road wheels and return rollers. The idea of using simple leaf springs on a modern military vehicle seemed absurdly backward. Yet when they tested the Jeep off-road, driving it across the same obstacle courses used to evaluate German vehicles, it performed astonishingly well. The simple suspension provided exceptional wheel travel, allowed the chassis to twist over uneven terrain, and proved nearly indestructible. Engineers watched in disbelief as the Jeep climbed obstacles that would have stopped a Kübelwagen, traversed ditches that would have required a half-track, and maintained mobility in conditions that would have immobilized most German vehicles. The secret was in the simplicity. The leaf springs could twist and flex, allowing the chassis to conform to terrain while maintaining wheel contact. The solid axles meant that dropping one wheel into a hole lifted the opposite wheel, rather than losing traction as independent suspension might. The simple, mechanical design meant nothing could break, because there was nothing complex to fail. It was engineering by subtraction, removing everything unnecessary until only essential function remained. The four-wheel drive system particularly impressed and disturbed the German engineers. Power flowed from the engine through the transmission to the transfer case, which could direct power to either the rear axle alone or to both front and rear axles simultaneously. Front axle engagement was controlled by a simple mechanical linkage that any driver could operate. German four-wheel drive systems were complex affairs requiring careful operation and specialized training. The Jeep system could be operated by soldiers who had barely learned to drive. When engineers disassembled the front axle, they discovered another example of American design philosophy. The front wheels were driven through simple universal joints, robust units that were neither elegant nor efficient, but were cheap to manufacture and easy to replace. German engineers would have specified constant velocity joints with careful seals and precision bearings. The Americans had used the crudest solution that would work and moved on. But the truly disturbing discovery came when they began examining manufacturing techniques visible in the vehicle's construction. Every body panel was stamped from flat steel sheet on massive presses. The fenders, hood, grille, all formed with simple dies that could produce parts at incredible speeds. The welds were quick tack welds, adequate for strength but not finished or ground smooth. The paint was sprayed on quickly without the careful preparation German vehicles received. Nothing was finished to a high standard. Everything was finished to an adequate standard, and adequate was clearly sufficient. Major Niepkamp ordered a complete parts inventory. Teams of technicians spent days disassembling multiple Jeeps, cataloguing every component, measuring every part. What they discovered was profoundly unsettling. One Jeep contained 4,182 individual parts, including every nut, bolt, washer and cotter pin. German military vehicles of similar capability contained between 8,000 and 12,000 parts. The Americans had achieved full four-wheel drive capability with fewer than half the components. Moreover, the parts inventory revealed extraordinary standardization. 42 different fasteners total across the entire vehicle. 42. German vehicles used hundreds of different bolts, screws, nuts, and washers, each specified, for particular applications. The Jeep used the same handful of fastener sizes everywhere, chosen for adequate strength rather than optimal strength. An engineer could maintain a Jeep with a toolbox containing perhaps 20 tools. Maintaining German vehicles required specialized tool sets numbering in the hundreds. The manufacturing implications were staggering. Wilhelm Voss, a production engineer from Auto Union, calculated that a Jeep could be assembled in approximately 1/10 the man-hours required for a Kübelwagen, despite the Kübelwagen being a simpler vehicle. The American design eliminated complex fitting, adjustment, and finishing operations. Parts bolted together quickly because tolerances were loose enough that everything always fit. Wiring harnesses plugged in because every connector was standardized. Body panels attached with simple bolts, rather than requiring careful alignment and adjustment. Dr. Porsche requested permission to conduct extended durability testing. 3 Jeeps were assigned to the testing facility and subjected to the same evaluation protocols used for German military vehicles. Each vehicle would be driven 10,000 kilometers over the Kummersdorf test course, a brutal circuit of mud, sand, rocks, water crossings, steep hills, and deep ruts designed to break vehicles and expose design weaknesses. German vehicles typically required extensive maintenance and repairs to complete this test. Many failed to complete it at all. The Jeeps required oil changes, 1 set of spark plugs, and routine lubrication. Nothing broke, nothing wore out. At the completion of testing, engineers disassembled all 3 vehicles and measured component wear. It was minimal. The engines showed normal break-in wear but no indication of impending failure. The transmissions were in excellent condition. The suspension components were unmarked. The bodies had acquired dents and scratches but no structural damage. One vehicle had been deliberately subjected to abuse that would have destroyed any German vehicle. Driven through deep water at high speed, operated at maximum RPM for hours, driven in low gear at full throttle up steep grades until the engine nearly overheated, subjected to violent off-road operation that lifted wheels completely off the ground. It suffered no mechanical failures. The cooling system, which German engineers had dismissed as inadequate with its small radiator and simple water pump, proved completely effective. The simple mechanical fuel pump, which should have failed under sustained high-speed operation, continued working perfectly. The crude transmission, which should have destroyed itself under abuse, shifted smoothly throughout testing. In January 1943, a report was compiled for submission to the Heereswaffenamt, the German Army Weapons Agency. It was 37 pages of technical analysis, measurements, test results, and engineering evaluation. The conclusions were devastating to German pride. The Americans had created a military vehicle that was superior to German equivalents in almost every measurable category. It was more reliable, more durable, more mobile, easier to maintain, and dramatically cheaper and faster to manufacture. Moreover, the Jeep represented a manufacturing philosophy that Germany could not match. The Jeep was designed from the beginning for mass production, with every component optimized for high-speed manufacturing rather than engineering elegance. Complex castings were eliminated in favor of simple stamped parts. Precision machining was avoided wherever possible. Assembly operations were simplified to allow semi-skilled workers to build vehicles quickly. The implications for American production capacity were terrifying. If the Americans could build vehicles this crude, this simple, this fast, they could build them in numbers that Germany couldn't hope to match. A nation that could design such a vehicle wasn't trying to out-engineer Germany. They were trying to outproduce Germany, and the Jeep proved they had the capability to do exactly that. Dr. Porsche's section of the report was blunt. The American Jeep represents a design philosophy fundamentally different from our own. Where we seek engineering excellence, they seek adequate functionality. Where we strive for precision, they accept roughness. Where we specify quality materials and careful manufacturing, they use common materials and rapid production. The result is a vehicle that works better than it should, costs less than it should, and can be produced in quantities we cannot match. This represents a serious threat. The report circulated through German military and industrial circles throughout 1943. Reactions varied from dismissive to alarmed. Some engineers insisted that German vehicles remained superior, that the Jeep's crude construction would lead to failures in extended service, that quality would ultimately triumph over quantity. Others recognized what the Jeep represented and were deeply concerned. Albert Speer, Minister of Armaments and War Production, read the report and immediately understood the implications. He had been arguing for simplified designs and mass production methods for German weapons. The Jeep was proof that this approach could produce superior results. He ordered German automotive manufacturers to study American production methods and develop simplified vehicle designs. The orders were largely ignored. German engineers couldn't bring themselves to build crude vehicles when they knew how to build excellent ones. The cultural resistance to American-style simplification ran too deep. Meanwhile, Willys Overland and Ford were producing Jeeps at combined rates exceeding 300 units per day. By 1943, production reached 60,000 vehicles per month. By war's end, over 640,000 Jeeps would be manufactured, more than all German military vehicles of all types combined. In North Africa, Jeeps proved their worth under combat conditions. British General Bernard Montgomery, initially skeptical of American equipment, became a Jeep enthusiast after seeing them operate in desert conditions. German forces, struggling with vehicles that broke down constantly in sand and heat, watched American units that seemed to have unlimited mobility. Rommel himself noted in his diary that American motorization was extraordinary, almost incomprehensible. The Jeep could go anywhere, carry anything, and simply would not break. In Russia, Jeeps delivered to Soviet forces through Lend-Lease became prized possessions. Soviet soldiers, accustomed to unreliable vehicles that required constant maintenance, discovered that Jeeps started in temperatures that froze German vehicles solid, ran on fuel of appalling quality, and continued operating after abuse that would have destroyed Soviet-built trucks. Soviet mechanics, trained to perform complex repairs with minimal tools, found they rarely needed to repair Jeeps at all. The contrast with captured German vehicles was stark. Soviet units that acquired German vehicles through capture quickly abandoned them. They were complicated, required specialized parts that didn't exist, broke frequently, and demanded maintenance skills that Soviet mechanics often lacked. Jeeps, by contrast, could be maintained by anyone with basic mechanical knowledge. Parts were interchangeable across all vehicles. The electrical system made sense. The engine could be overhauled with simple tools. In the Pacific, Jeeps operated in conditions that would have destroyed European vehicles. Tropical heat, torrential rain, jungle trails, beach landings in salt water, island-hopping campaigns where vehicles were sometimes partially submerged during landing operations. Jeeps survived it all. Marines discovered they could drive Jeeps directly off landing craft into surf up to the headlights, drive inland through jungle, operate them continuously in 100-degree heat and 100% humidity, and they kept working. Japanese forces, whose military vehicles were generally lighter and less capable than even the Kübelwagen, were astonished by American motorization. Captured American equipment manuals were translated and studied, revealing yet another American advantage. The Jeep's technical manual was written for common soldiers, not trained mechanics. Instructions were clear, illustrated with simple drawings, organized logically. Any literate soldier could perform routine maintenance, and most repairs using the manual as a guide. German technical manuals were written for qualified mechanics and assumed extensive prior knowledge. In France, following the D-Day invasion, the mobility difference became even more apparent. American forces moved with speed and flexibility that German commanders found bewildering. Supply lines stretched hundreds of miles, maintained by endless convoys of jeeps and trucks that simply did not break down. German forces, increasingly short of fuel and vehicles, found their mobility collapsing, while American units seemed to go anywhere, anytime, regardless of conditions. German soldiers who captured jeeps tried to keep them running as long as possible. They were faster, more reliable, and more comfortable than German vehicles, but maintaining them became impossible as American advances cut off captured supply dumps. The jeep's need for parts was minimal, but when something did break, only American parts would fit. The interchangeability that made jeeps easy to maintain in American service made them impossible to maintain in German service without access to American supply chains. In late 1944, a damaged jeep was recovered from an American unit near Aachen and sent to the Kübelwagens facility for examination. This vehicle had been in service for 18 months, had accumulated over 45,000 kilometers, according to its odometer, and showed extensive combat damage. German engineers were curious whether extended service had revealed reliability problems that hadn't appeared in testing. The vehicle was disassembled for the third time in 3 years. Different engineers, some of whom hadn't participated in the original 1942 evaluation, examined the worn components. What they found confirmed the original assessment. The engine, despite having 3 times the service life of typical German military vehicle engines, was in excellent condition. Cylinder bores showed normal wear but were nowhere near requiring overhaul. Bearings were intact. The crude crankshaft was still properly balanced. The simple valve train showed minimal wear. The technician performing the teardown estimated the engine was good for at least another 30,000 kilometers before requiring any significant work. The transmission, which had obviously been operated hard under combat conditions, was in similar condition. Gear teeth showed normal wear patterns but no damage. The simple synchronizers were still functioning correctly. The transfer case, covered in mud and showing impact damage from ground contact, still operated perfectly. When cleaned and lubricated, it shifted smoothly through all ranges. The suspension, bent and battered from hard use, still functioned. One leaf spring had cracked but hadn't failed completely. The simple solid axles were unmarked. The crude universal joints showed wear but were still serviceable. The fact that the vehicle remained mobile despite obvious combat damage and hard use spoke to the fundamental soundness of the design. By this point in the war, German engineers had stopped being offended by the Jeep's crude construction and began recognizing it as a different kind of genius. The Americans hadn't out-engineered Germany. They had redefined what engineering meant in the context of total war. German vehicles were precision instruments, carefully designed, beautifully made, technically sophisticated. They were the products of a manufacturing tradition that valued craft, quality, and engineering excellence. Each vehicle was almost a custom, creation fitted together by skilled workers, adjusted carefully, finished properly. In peacetime, this approach produced superior vehicles. In total war, it was a catastrophic disadvantage. American vehicles were industrial products, designed from the beginning for mass production, built by semi-skilled workers using simple tools, assembled quickly without custom fitting or adjustment. Quality control meant ensuring parts functioned adequately, not that they were perfect. Finish meant adequate protection from corrosion, not beautiful paint. Engineering meant finding the simplest solution that would work, not the best theoretical solution. The result was vehicles that could be produced in unlimited numbers, maintained by anyone, repaired quickly with common parts, and operated reliably under conditions that would destroy more sophisticated designs. Germany was still handcrafting precision vehicles, while America was mass-producing crude ones. The crude ones were winning. In March 1945, as Allied forces crossed the Rhine and began the final advance into Germany, scattered reports reached Berlin of captured American vehicle parks. Intelligence estimates suggested the Americans had more vehicles in Western Europe than Germany had produced during the entire war. The numbers seemed impossible, but reconnaissance confirmed them. Endless rows of jeeps, trucks, half-tracks, all standardized, all interchangeable, all part of a logistics system of staggering scale. A German officer who had commanded a vehicle maintenance company wrote in his diary, "We have 12 vehicles, 6 are broken, we have no parts. The Americans have thousands of vehicles, none are broken. If one breaks, they replace it. We are trying to fight an industrial nation with a craft-based economy. It's like fighting tanks with horses." At Kummersdorf, the testing facility was being evacuated as Soviet forces approached. Engineers were destroying documentation and preparing to flee. The 3 jeeps that had been tested in 1943 were still there, still running. Junior engineers had been using them for transportation around the facility for 2 years. They had accumulated over 100,000 kilometers each with nothing but routine maintenance. A young engineer named Schmidt, who would survive the war and emigrate to America in 1951, later wrote about his last day at the facility. "We were supposed to destroy all captured equipment before evacuating. I was assigned to disable the American vehicles. I couldn't do it. Those jeeps had been more reliable than any German vehicle I'd ever known. I removed the distributors and buried them nearby instead. I like to imagine that whoever found those jeeps after we left was able to get them running again. They deserved to survive." The jeep's influence extended beyond its immediate military impact. German engineers who survived the war and returned to civilian industry carried lessons learned from examining American vehicles. The post-war German automotive industry, rebuilt from ruins, incorporated American mass production methods. The emphasis on standardization, interchangeability, and simplified manufacturing that German engineers had resisted during the war became standard practice afterward. Dr. Porsche, who had written scathingly about the Jeep's crude construction in 1943, spent the late 1940s designing the Volkswagen Beetle for mass production. The Beetle incorporated many lessons learned from studying American vehicles: simplified manufacturing, standardized parts, design for assembly by semi-skilled workers, adequate quality rather than perfect quality. It became one of the most successful vehicles in history. The technical details that German engineers discovered during their examination of the Jeep revealed layer after layer of American design philosophy that contradicted everything they had been taught. The steering system, for instance, was a simple Rosscam and lever design that any mechanic could rebuild in a few hours. German vehicles used more sophisticated steering systems with tighter tolerances and better feel, but they required specialized knowledge to maintain. The Jeep's steering was agricultural in its crudeness, but it worked perfectly and never failed. The steering linkage used simple ball joints that could be replaced individually rather than as expensive assemblies. Every component was designed for field replacement. The brake system told the same story. Hydraulic brakes with a single master cylinder feeding all 4 wheels through simple steel lines. German engineers noted that the system lacked any sophisticated pressure regulation or proportioning. The brake drums were simple castings, the shoes lined with basic friction material, yet the system worked reliably under all conditions. When they tested the brakes to destruction, running the Jeep down steep grades repeatedly until the brakes glowed red, the system continued to function. The simplicity that looked like ignorance was actually sophisticated design for reliability and maintainability. The fuel system was equally revealing. A simple 15-gallon fuel tank mounted at the rear of the vehicle, a mechanical fuel pump driven by the camshaft, and a basic carburetor. No fuel filters beyond a simple screen in the tank. No sophisticated metering systems. The carburetor would run on almost any gasoline, even contaminated or low-octane fuel that would have caused German engines to knock and ping. American engines were designed to tolerate poor fuel because American planners knew that combat forces couldn't always access high-quality gasoline. German engines, optimized for proper fuel, frequently failed in the field when forced to run on captured or contaminated gasoline. The ignition system demonstrated the same philosophy. A simple distributor with a single coil, basic spark plugs, and a 6-volt electrical system that was considered obsolete by German standards. Yet the system was completely reliable. The low voltage actually proved advantageous in wet conditions, producing fewer short circuits than more sophisticated 12-volt systems. The distributor cap was sealed against moisture. The spark plug wires were heavy-duty and waterproof. Everything was designed for the assumption that the vehicle would operate in terrible conditions with minimal maintenance. Even the small details revealed American thinking. The hood was held down by simple spring clips rather than complex latches. It could be opened in seconds without tools. Every fluid checkpoint was clearly marked and easily accessible. The oil dipstick was large and easy to read. The radiator cap was positioned for easy access and filling. The battery was mounted in a location where it could be removed and replaced quickly. German vehicles typically had batteries mounted in cramped locations requiring partial disassembly to access. The Americans had designed every aspect of the vehicle with the assumption that maintenance would be performed by tired soldiers in terrible conditions, with minimal tools and poor lighting. The body design itself was a masterpiece of simplified manufacturing. Every panel was a simple stamping with minimal compound curves. The fenders were formed from flat sheet steel with simple bends. The hood was 2 flat panels joined at a peak. The grille was a simple pressed steel assembly. None of it was beautiful by German aesthetic standards, but all of it could be manufactured quickly on simple tooling. German vehicle bodies required complex dies and multiple forming operations. American bodies could be stamped out rapidly on basic presses. The seats were simple frames with canvas stretched over them. No springs, no padding, no adjustment mechanisms. They were uncomfortable by civilian standards, but perfectly adequate for military use and could be manufactured for a few dollars. German vehicle seats were typically more sophisticated with springs and adjustments, but they cost more to build and were more prone to failure. The Jeep seats would last for years and could be recovered in the field with nothing more than canvas and a needle. The windshield was hinged at the bottom and could be folded forward onto the hood, reducing the vehicle's profile for combat operations. The glass was simple flat plate that could be cut from stock sheets. German vehicles used more sophisticated curved windshields that required expensive forming operations and couldn't be replaced with simple flat glass. The American design meant that a Jeep windshield could be replaced anywhere in the world with locally sourced flat glass cut to size. The instrument panel was Spartan beyond belief by German standards. A speedometer, an ammeter, an oil pressure gauge, a temperature gauge, and a fuel gauge. That was the complete instrumentation. German vehicles had more comprehensive instrument panels with multiple additional gauges monitoring various systems. The American approach was that if the engine was running and the gauges showed normal readings, the vehicle was fine. If something went wrong, it would show up on one of the basic gauges, or the engine would simply stop. No need for sophisticated monitoring of every system. The lighting system used the revolutionary sealed beam headlights that German engineers found fascinating and disturbing. The entire headlight was a sealed unit containing the bulb, reflector, and lens as a single component. When a headlight failed, you simply removed the retaining ring, pulled out the failed unit, and plugged in a new one. No aiming, no adjustment, no careful alignment required. German headlights required the bulb to be changed, then the reflector aimed precisely using adjustment screws and gauges. An operation requiring skill and time. The American system could be completed by anyone in less than a minute. The electrical wiring throughout the vehicle used color-coded wires and simple junction blocks. Every circuit was protected by fuses clearly labeled on a panel. German vehicles used more complex wiring systems that required technicians to trace circuits using diagrams. The Jeep's wiring could be troubleshot by following color-coded wires and checking fuses. The system was foolproof by design, intended to be maintained by soldiers with minimal electrical knowledge. Even the paint revealed American priorities. It was applied quickly without extensive preparation, just enough coating to prevent corrosion. German vehicles received multiple coats with careful preparation between coats. The finish was more durable and more attractive, but it took far longer to apply. American vehicles came off the production line with barely adequate paint that would need touching up in the field. But they came off the production line much faster, and in war, speed of production mattered more than perfect finish. The more German engineers studied the Jeep, the more they realized that every single design choice had been made with production speed, maintenance simplicity, and field reliability as the primary criteria. Performance, comfort, efficiency, and engineering sophistication were secondary considerations at best. This represented a fundamental philosophical difference in approach to military equipment. German military equipment was designed to be the best possible solution to a problem, with cost and manufacturing complexity as secondary concerns. American military equipment was designed to be an adequate solution that could be manufactured quickly in enormous quantities and maintained by minimally trained personnel. The German approach produced superior equipment in limited quantities. The American approach produced adequate equipment in overwhelming quantities. The war was demonstrating which approach was more effective. Superior equipment that wasn't available in sufficient numbers or couldn't be kept operational due to maintenance complexity was ultimately inferior to crude equipment that was always available and always worked. The psychological impact on German engineers cannot be overstated. These were men who had spent their entire careers pursuing engineering excellence. They had been educated in institutions that valued precision, sophistication, and technical innovation. They worked in industries that prided themselves on quality and craftsmanship. They came from a culture that looked down on crude, simple solutions as beneath the dignity of proper engineers. The Jeep forced them to confront the possibility that their entire approach to engineering was flawed, at least in the context of total war. Some engineers couldn't accept this. They continued to insist that German designs were superior and that the Jeep's success was simply due to American industrial capacity. If Germany had America's resources, they argued, German engineering excellence would produce far superior results. Other engineers recognized that the Jeep represented something more fundamental, a completely different way of thinking about design and manufacturing that was better suited to modern industrial warfare. The debate within German engineering circles became heated. Younger engineers, less invested in traditional approaches, argued that Germany should immediately adopt American-style simplified designs. Older engineers resisted, insisting that compromising on quality and sophistication was unacceptable. The argument was never resolved because Germany lacked the industrial capacity to implement American-style mass production, regardless of which philosophy prevailed. German industry was already operating at maximum capacity producing existing designs. Retooling for simplified designs would have reduced production in the short term, and Germany didn't have time for short-term reductions. But the recognition that American design philosophy was effective in ways that German philosophy wasn't represented a profound shift in thinking that would influence post-war German industry. The engineers who examined the Jeep at Kübelwagens and survived the war carried those lessons into the Reconstruction period. When German industry rebuilt after 1945, it incorporated elements of American mass production philosophy while retaining traditional German emphasis on quality. The result was the modern German automotive industry, which combines efficient manufacturing with high quality, the best of both approaches. The Jeep itself continued its evolution. Later versions added improvements like better transmissions, more powerful engines, and refined details, but the basic design philosophy remained constant. Simplicity, reliability, maintainability, and producibility over sophistication and perfection. That philosophy, so alien to German engineers in 1942, became standard practice in military vehicle design worldwide after the war. Modern military vehicles of all nations reflect lessons learned from the Jeep, standardized components, simple maintenance, field repairability, and design for production. The German engineers who examined captured Jeeps in December 1942 were looking at the future of military vehicle design and didn't recognize it. They saw crude American workmanship where they should have seen sophisticated design for manufacturing. They saw sloppy tolerances where they should have seen intentional design for reliability. They saw inadequate engineering where they should have seen a fundamentally different and more effective approach to solving military transportation problems. By the time they understood what they were looking at, it was too late. America was already burying them under an avalanche of crude, simple, reliable vehicles that just kept working no matter what.